Good afternoon, everyone. Good afternoon, all dear participants. Good afternoon, and welcome to the second day of this machine learning webinar. Good afternoon. Can I get some response in chat box? Am I audible? Can you see my screen? Is everything proper? Can we start with the session on machine learning? So welcome to this day 2 of machine learning with Python, workshop on machine learning with Python. And I hope in the previous session we have discussed about the introduction of machine learning. Today we'll go through some of the steps of machine learning with practical implementation as well by collecting a data, and then we go and implement it directly in a collab file, and by the end we'll try to build together it as a project. So we'll do all the things in this session by following the steps involved in machine learning, and that is going to be the agenda for this session. So we'll wait for a couple of minutes and then we'll start with the session on machine learning. In the meantime, can I get some response? Good afternoon, dear participants. Good afternoon, all. So starting with the steps in machine learning, we have different pathways to be gone through, like in a hierarchical way. So all of the things are dependent on data. So data is the important topic here. You need data to proceed with your machine learning. Even though in the introduction session I have shown you a graph of how this process happens. You have a data, you give it to your like you do the pre-processing and the analysis, and then you give it to your model, which is a statistical tool for making prediction, right? So for all these tasks, the main raw material for us is going to be data, and the quality of data is important. So first step is data collection. So I'll be briefing about data collection, and then we'll go into pre-processing where we'll discuss about pandas library, how you can load this data set into Python notebook, and then how you can tween it and how you can work with it will be discussed in the pre-processing. And then after that we have some pre-processing which is required for our like machine learning task itself. Like we'll be doing some basic pre-processing on account of machine learning. So we'll be keeping that in mind and proceeding in that way. And after that we go into some part which is called as train test split, which is usually done to evaluate or keeping some portion of your data hidden. It's like giving a test, and then with your like you are asking your student or your machine learning algorithm to learn, and then you are going to make it to give some answers for it to make prediction. And then we go with feature selection, and these concepts come under machine learning. So since you have a lot of features in your data set. We look into that features and target and all. So to reduce the noise and complexity, we go with feature selection. Then we need to select a model for your particular task. So based on what category of project you are doing and what is the problem you are going to solve, you move into model selection and training. And then we move into predictions, and then we evaluate and improve the model. So that's going to be the task for this steps in machine learning. And for data collection, usually I'll tell. So you have some websites which you can look into. For example, you can look into sites like Kaggle. You can look into sites like UCI Machine Learning Repository, or you can utilize Google Dataset Search. And apart from this, we have a lot of data collection sources. But before that, downloading from this is fine, but how is the data is actually created or collected? So that is an important task. So usually data can be collected. It can be, for example, if you are working in a company and if your company is planning to collect or store their data, so they'll be creating a database and they will be structurally formatizing it, saving it. Okay, so all the entries will be saved there. So that is called as a data, and it's a database. So companies can do that, and then later on they can proceed with machine learning to do it and use it for a data science application to find whether how to improve their sale value and something like that. And also, for example, if you are an enthusiast and you want to do some contribution for the domain of healthcare and you are planning to collect some medical information, so what you can do is, as a person, you can go and contact with a hospital, and with the consent of the patient you can register or record. For example, if you are planning to create a data set on diabetes, where you are going to collect the information such as the patient, what's their age, what is their blood glucose level, what is their blood pressure, and all these medical details without their particular personal information. We are just collecting the medical information only. So for these kind of data and all, the patient consent is really important. You can't go and take it. Okay, they should be like comfortable with giving it. And like this data can be collected, and if you are a student, you can go and use your Google Forms and all to create a survey on some data, and you can create a survey, and that can also be a data. And if you find any data which is available in the web, you can do something known as web scraping, which can be done to collect the data which is available in the online. For example, if you are planning to collect or create a data or a data set which is based on the movies. Okay, so in movies, like what is the top 1000 movies and all, if you go into site something called as IMDb, so you can get the movie list and all, they'll be ranking it. And if you are planning to collect that data set, like for example, in that site you will be having what's the title of the movie, who is the director, what's the synopsis, what's the rating of the movie, which year it has been released, and what's the guidance given, what is the certification given, and what type of genre it is. So all these things will be there in the particular site, and it will be having for 1000 or 10,000 movies. And it's really not wise to collect one by one. So you can use web scraping, and you can automate this process by running it in a loop, and how many movies they have, you can collect it and you can load it in a CSV or Excel file. That is a part of data collection. So these are some data collection which you can start on your own and then create your own data set. You can publish this even in some of these sites which are well known for like a hub for data. So if you are planning to collect the data, for example, in some scenarios, if you are a student and you can't directly go and proceed and collect a data, it's a difficult task. So in such case, if you are looking for an data which is already available, so there are people like these who are, their task is to just collect the data and they post it in the open source or they'll sell it. So like that, we have a lot of data sets which is already available. So if you want, what you can do is you can go into your sites such as Kaggle or you say machine learning repository or just Google, and if you search, if you are having something in your mind, for example, if I am planning to create, or if I need a data, I want to work on a data which particularly goes with heart disease. So what I can do is I can search, is there any heart disease based data set which is already available. So if I am planning for finding something like customer churn prediction or sale prediction or stock market price prediction, so I can directly go and get it, or I can search for which is already available. So these are some processes. And for these, what you can do is you can look into these sites. So let me show you first. Let us go into Kaggle. Before that, can I just get some response in chat box from anyone? Good afternoon, dear participants. Can we start with data collection? So let me go with kaggle.com, and here if you go into the datasets, you will be having a lot of datasets which is available. So you can search for your datasets too if you are interested. I hope you can go and call something like diabetes or heart disease. These are very basic datasets. And we have some datasets and they are ranking as well. So some datasets, if it's not good, you can't find it ranked well. If some dataset is considered good, you can find some parameters for it. So we have some PIMA Indians diabetes database. It's a old one, but still it's one of the good for practice, for basic practice. So here we look into what all we have in the dataset. You can look into the dataset, like these are all the columns. We have the number of pregnancies that particular patient had, what's the glucose level, what's the blood pressure, what's the skin thickness, what's the insulin, what's the body mass index, what's the diabetes pedigree function, what's their age, and what is the outcome. And in outcome we have two different classes, which is 1 and 0. So we have a lot of ones and zeros here. So if you want to understand what is 1, what is 0, you have to look into what they say here. So according to the context, what it is given here is, so if it is 1, it means that the presence of diabetes, and 0 means absence of diabetes, and we have something like 268 ones and 768 zeros in this dataset. So nearly 25% of our dataset they have diabetes. So if you are interested, what you can do is you can click download. You just need an account here. So you can download this CSV file, and this is my data I am talking about. So I have a dataset which is available. So this is the patient details. It's one of the very basic dataset. If you are familiar with machine learning, this is just a simple dataset. But if you are new to this, I'll suggest you to work with this dataset because it's good for practice on the target. This is going to be a classification kind of problem scenario with you have labels, and it's a classification one. You are not predicting any continuous value. You are just going with whether it is going to be a yes or no question, 0 or 1, hot or cold, diabetes is having or not, yes or no kind of scenarios. So with these things, these are all our features are going to be. So if I want to load it into my workflow of Python, what can I do is I can utilize some of the libraries. Okay, so this, if I want to work for machine learning, I have to load this in particular way in some other like IDE or any environment where I can work on it, because here you can't manually go and perform machine learning. So for that task, what I'm preferring is I'll just don't save these changes which I have done, and I can suggest you one common notebook format, which is Google Colab. You can search Google Colab in internet. You'll be getting it. First you have to connect to it. You can create a new notebook. This is the Python notebook, and you can rename it also here. You can create new cells and run the code here. And first let me just upload the dataset here. So in the local file here, so let me just double click and click upload, and let me just go and upload the dataset which I have took. So now the dataset is loaded here, diabetes.csv. So this is available, but how am I going to use it in the Python here? So for that task, we are dependent on a library which is called as pandas. So we'll see on working with data in Python using pandas. Before that, you can also look into UCI machine learning repository or Google dataset search, and Google dataset search and all is going to give you different pathways. Google dataset search. So this is going to give you like directions where you can download the dataset. For example, coronavirus, COVID-19, or if you search with keyword, it is going to give you like what all sites have this. It includes Kaggle or some other sites too. You can download or get some lead from here. So it is going to be a collection or which tells you where all the data are available. So that's it about the data collection. Just want to know that whether the data collection part is clear. If it's clear, I can proceed with working with data in Python using pandas. Can we start with pandas? Working with data in Python with pandas. So pandas is a Python library which can be used to work with data sets. So we can use this to load the data and then we go into the next pre-processing and all. So pandas is a Python library for working with data sets, and it has functions for analyzing, cleaning, exploring and manipulating data. And pandas is fast and it has high performance and productivity for the users. And pandas allows us to analyze big data and make conclusions based on statistical theories, and it can clean messy data and make them readable and relevant. Relevant data is very important in the concepts of data science as well as machine learning. So to install pandas, you can go with pip install pandas, and for using pandas you can call import pandas, and it's a Python library, and every time if you want to use any methods or things inside of pandas, you have to go and call pandas dot and all. So instead what you can simply do is you can go with import pandas as PD, which is a short denotation of pandas, which can be used to load or integrate and work with pandas. So first we start with some data analysis which is given from pandas. First step is you want to load your data. So how you can do is you can go with pd.read_csv. So this is an option for reading a CSV file, and if you pass a path of your CSV file, your CSV data is loaded, and it is loaded into the variable which is dataset. So let us try to load it here. For pandas as PD. So we'll go with data equal to pd.read_csv diabetes.csv, and let me paste the path of it here. It is going to be data.head, and this is going to be the data set we have. So this is the data we have seen in the CSV file. Now it is loaded in the IPYNB file, so we have the data which is loaded here. So from here we can use this data, because this is loaded the CSV, but it is a data frame in pandas. If you just check what's the type of data here, it is going to give you it belongs to pandas data frame, because it has lot of functions inside of it, so we can use it for working. So let us go and explore that, starting with analyzing the data. So you can go and analyze this data by using head, tail, info and describe. So if you go with data.head, you will be getting the first 5 rows, and then if you go with, see here, the first 5, and then if you go with .tail, it is going to display the last 5 rows. This is the last 5, and then going with data.info to get information about your dataset. The information which is going to be what's the count we have, what data type they have. For example, age is integer, BMI is all float values, outcome is integer, and we can also go with data.describe, and this is going to give you a statistical summary of the numerical columns you have. For example, like pregnancies, glucose, blood pressure, these columns, and their what is the count, what's the mean value, what's standard deviation, what's the minimum value, 25th, 50th, 75th and maximum. So the respective values can be obtained like this using data.describe. So moving into the next analysis, something like you can go and call some like variables inside, like columns, shape, data types and index to get information about that. For example, you can go with data.columns. So it gives you the column names like pregnancy, glucose, blood pressure, all the details in a list. And you can also go for what's the index we have, what's the index information. It gives you a range like what's the starting, ending, and then what's the step it has been followed. You can also go with data.shape to get what's the number of rows, columns you have. So you'll be getting a tuple with number of rows at 0th index and number of columns in the first index. So it is going to be 768, 9. And then we can also go with data. I hope we can do d types, which you can get it in the info itself. But here you can go and pass to get the data types, which is going to be pregnancies, glucose, blood pressure, what's the data type they particularly follow. So these are all the basics of data analysis. And particularly now, if you want to pick a single column, what you can do is you can go and call it inside square bracket, and then with that you can pass some analyzers, something like, for example, if I want to just call data, I'll be getting all the columns. And if I want a single column, I can go and pass glucose here to get a single column. So if I want this is a column glucose, and if I want multiple columns, I have to use a matrix format or a 2D format and go with glucose comma, I'll go and call outcome. So this is what I get. So I particularly now can pick the columns. So after picking this, for example, I can go and call value underscore counts. So it is going to give me the count of values. Okay, so this may be confusable. I'll just go and pass only one input. Like for example, I hope you can pass it in the outcome. So when I go with outcome and go with value counts, I go with, like for example, 500 is available, which means 0 is available in 500 rows and 1 is available in 268 rows in the outcome. And you can also use some visualization tools if you want. For example, you can go and call a library which is called as Seaborn, import Seaborn as SNS, and the SNS has something known as count plot, where simply what you can do is you can pass the data and then which column you want to explore. So the column which you want to explore here will be something like, you can go and mention outcome, and if I do it, I'll be getting something like this, which is going to be the same representation of 500 and 268, but in a visual way. You can see, right? For example, 0 is in 500 places and 1 is in 268 places, kind of places. So these are all this. And moving next into the next part, like this, you can also use some other properties. For example, like selecting this, right? You can go and just call unique, and the unique is going to be giving you a list of what all unique values you have, unique in that particular column. So you'll be getting that. So you have ones and zeros, that's the unique thing which is available. So we got that. And you can go and call, for example, let me call age column, and if I want, I can go with dot mean to get mean value of that column. If I want, I can go with the median value, which is the middle value, and if I want, I can go with the mode value, which is the most repeating one. So these are all some techniques which you can utilize. So 22 is the mode value, so if you want, you can pick 0 alone. You'll be getting that particular value only. Apart from that, yeah, so you can select a single columns or dual columns, and you can slice a series, like these are all series. And for example, if you want to pick a particular row, what you can do is you can use iLocate or locate option. Particularly data.locate, I'll go with 3 here, so it is going to pick the third index. So in third we have pregnancy 1, glucose 89, blood pressure 66. Can we check? So in 3, pregnancy 1, glucose 89, blood pressure 66, and so on. So you can go and select like this with single column, or if you want to slice, for example, 3 till 4, like 8, it is going to give you till 7, like Python. So it is, you can go and manually call some part of your data, and then you can ask it to display that. So that is analyzing the data. Locate, and the iLocate can be used instead of, if your index is something else instead of numbers, what you can do is you can use index location. So instead of exactly matching the locate, it is going to search for the index and pass numbers like from 0, 1, 2, 3, like indexing. Yeah, so finally, if you are planning to create a new column, for example, if I am planning to create something like, let us go and create a new column. So if I want, I can go and create a new column, and if I want 1 everywhere, I can just set this to 1. So what happens is, in a new column in data, we'll be having a column in the name new with just only 1 in all the places. And similar way, what if we want to pick another column? For example, here I want to pick the same values of glucose. Okay, so this now new will be having the values of glucose. The new will also have the same glucose value. So if you want, you can also do some manipulations. For example, divide this thing by 10 and then store it in the new column. So now glucose is divided by 10 and stored it in the new column. So you can see decimal points now, 14.8, 8.5. These are all just for practice. Like in some necessaries, you can go and utilize this. And what if I don't want to have this? If I want to just remove this or I want to drop this, what I can do is I can go and call drop and pass the column and the axis. If you are deleting columns, you have to go with axis 1, and if you are deleting rows, you have to go with axis 0, and in place equal to true will make sure that the result is updated in this variable itself. So going with that, we can go with data.drop, and I'll go and drop new column with axis 1 and then in place equal to true. Let me drop it, and what is the result do I have here? So I'll go with data. So the data now don't have that new column which is dropped actually. So you can go and drop multiple columns, or if you want to drop any row, what you can do is you can go with drop, mention the number you want to drop. For example, I don't want a 0, and the axis is going to be 0 because it's a row wise removal, and then in place equal to true. And this is going to make sure that the 0th entry in the index is now deleted. So if you go with data, you won't be having that. See here, it starts from 1. A particular row on 0 has been deleted. So it's a way you can utilize. You can go and do it for multiple columns as well, or multiple rows as well. And what if I want to rename? So if I want to rename, I have to go and pass a parameter which is columns, and I can go and create a dictionary of key and value. Key will be the old name and value will be the new name which I want to replace now. For example, this diabetes pedigree function is a bit lengthy, so I can just call rename and then go with columns equal to, I'll create a dictionary and go and pass the exact name, diabetes pedigree. If you are not familiar, just copy and paste this function, and then you can go and rename it to whatever you want. I'll go with something like a short form DPF, and let us view it. Okay, so the update has been done, but it hasn't been stored. You can try with in place equal to true, or else we can just store it in a variable once again. Like you can store it in the data itself. Now it's done with in place. So if you check the data, we'll be having renamed way, which is DPF. So we have that now renamed in that format. So this is renaming and all. And if you have two different data sets, you want to combine them along row wise or column wise, you can decide and then go and use pd.concat. And if you want to create a new index, you can set index of some other column and then use it here. So if it's clear, we can proceed with data pre-processing with pandas as well as machine learning concepts. So these are all the basic tools from pandas for handling the data. Is it clear? Can I get some response in chat box? So starting with data pre-processing here or data cleaning, they both have the same meaning, which means nothing but fixing unwanted or improper data in your data set. And this will improve the accuracy of data by removing or correcting inaccuracies, missing values, duplicates and irrelevant data. And it can make the data more consistent and reducing the risk of errors in downstream processes. So first main thing, whenever you go with your machine learning concepts, just go and check your data has null values or not, because it is mandatory to not go with any data which has null values. Null value is a place where there is no entries has been available or not a number value is there. So what you can do is you can either remove it or you have to manipulate. For example, let us do a sample with the data set. So I'll go into Kaggle, which is a site. I'll go and call for Titanic, which is a data set. And why am I particularly going into this data set is I hope this has null values. And let me just download this data. Yeah, this has been done and I can load it. So in the data, I'm going to just newly create another variable and then load this data set, which is train and test 2. So going with data.head. So let us explore with these tools. Okay, this looks like they have did something to this data set. They have used one hot encoding and this data set is not proper. Like you want the raw data set. So let us try to pick the raw data set. We'll go and use this particular data set. Yeah, this will be fine. Titanic.csv, 12 columns. We'll load that. Copy the path and let's paste it here. Data.head. Fine, so this is the raw data we have of the Titanic incident. So you can go and first check for it with the shape and what all the pre-processing tools we have seen, you can apply it. And you can also go with data.isNull.sum, which is going to give you how many null values you have in the respective columns. And what we can see is, and the reason for why we are summing this is, if you just go with isNull, you'll be getting a lot of booleans, and wherever it is true, which means that it has that particular place as a null value. See here, NaN is there in the cabin. 3 times in the first 5 entries, you can have true there. And just to get a summary of it, you can use sum to summarize it and then give you the sum of available true. True is considered as 1, so everything is 0 here. Apart from that, what all things you have, that will be summed here. And then you have a column which is called as age, which has 177 null values. And then you have a column which is called as embarked, which has 2. And you have a column which is called as cabin, which has 687, which is very high null values there. In such cases, if there is a lot of null values, you can either consider even dropping that particular column, because a column with this much null value, if you look at the percentage, you totally have 891 columns, 891 rows. Among that, you have 687 rows having null values. In this particular column is not a good scenario. For example, data of, or if you just want 687 divided by 891, so nearly 77% of the data is having null values, which is not a good one. Anyway, so we'll look into it. So what all things you can do if you found this null value is, you can either go and impute it or you can go and drop it. So imputation is something like you can go and manually change some values. For example, if the age is not available, what you can do is either replace the age with the mean value of that column, which means what is the average age, just go and replace it in the null values. Or you can drop the respective rows. Wherever you have null values, you can drop it. So it is based on the scenario and particular amount of data you have and the quality you have to decide it, because if you drop it, you will be losing other informations. And if you replace it, you are actually going with the data which is uncertain, because it's either a true one or a fake one. It's a manually manipulated one. So you travel between these two. It's like a fine line. You have to travel between these two. And if you are planning to impute it, you can fill the null values with fill NA and pass the value and pass in place equal to true. So you can go and call, for example, data of particular, let us call age, and then dot fill NA, and you can pass something like data of age dot mean value, and I can go with in place equal to true. So fill it with null value. So if I just go and got the data, so if I just now check for null value in that particular thing, we won't be having null values in the age, because that is now filled with the average value. So the age now has been dealt with. You can see the 177 null places has been done. Or what if the embarked, we can see only 2 is not available, it's the station. So if I want to just remove that particular column, what I can do is I can go and like drop it with the drop NA. You can particularly go with in place equal to true to save it. So you can go and call data dot drop NA, and you can go with in place equal to true. Embark. Okay, here you can use drop any to completely remove all the null values. You can't particularly go for a single column and it is going to remove the entire thing. That's a problem, and you have to be careful while using this drop any. And if you have any duplicate values, you can check it by using dot duplicated. Any duplicated rows will be shown here, and if you want to drop those duplicates, you can go with dot drop underscore duplicates within place equal to true. For example, if you want to check data dot duplicated, you will be getting booleans once again, so you can go and call dot sum to get a summary of that. Sorry, this should be like this. And if you have, in case here we don't have duplicates, if you have, you can go for drop underscore duplicates to drop that, like mentioned here. So now moving into the pre-processing of machine learning, these are all basics. Apart from that, mandatorily it is suggested before going into the machine learning algorithm, you have to go with feature scaling, encoding, imputing null values, and outlier detection and handling. So let us look into feature scaling. So feature scaling is a method used to normalize the range of features of data, and feature scaling involves modifying values by methods like normalization or standardization, and it helps to avoid bias in machine learning models. And why we actually perform scaling is, for example, if you have multiple columns like age, weight, and length. So when dataset has numerical features and each of them in different scale, machine learning model, the statistical tool, when you try to give it to learn, what it can understand is sometimes it can put weight on features with larger scale. Something like, for example, age will be like 1 digit to 2 digit maximum. Maximum it can go to some few places. If some person in your data set is 100 years old or more than that, you will be having 3 digit. Mostly it will be average, it will be in the 2 digit scenario. If they are very small children, you will be having in 1 digit. And weight, mostly it will be 2 to 3 digit. Average it is around 2 digit to 3 digit. And length, particularly if it is mentioned in centimeter, you will be having mostly in 3 digits. And this scenario where your length is a 3 digit value, weight is a 2 digit, age is a 2 digit, your algorithm may misinterpret and then understand that length is an important feature, so I'll go and pick that as my important one and I'll give more weightage. So based on the length only I'm going to decide, and I'll ignore age and weight. This scenario can be done, and to particularly avoid this, we go with something known as scaling, which helps to contribute all features equally. So here what we can do is, either you can go for 2 steps, either you can pick normalization or you can go for standardization. So if you go for normalization, it is a method of scaling the data by fitting the data points between a range of 0 to 1. So how to do is, you can apply this particular formula, x new equal to x minus x minimum divided by x max minus x minimum. So if you apply this particular formula, you will be having something like, you can do it with min max scaler. So for example, let us try to do it here. So the minimum value, if you pick, it's 2. So and maximum value is 12. So let us apply it for the minimum value itself. So it's going to be 2 minus 2, which is 0. So the entire thing goes to 0 now. So for lowest value it is 0, and what's the highest value? 12. So if you apply that, it's 12 minus 2 divided by 12 minus 2 once again. This entire thing gives 1. So now this maximum value is turned into 1, and anything beyond or between that will be between a range of 0 to 1. It will be in the decimal points. If you do this for each column, it's a univariate approach, so the changes will be happening univariately and the changes will be implied here. That is about scaling. And this is normalization. By doing it, it can be done with min-max scaler. Or if you want, you can also go for standard deviation, where this converts all the data points to have a mean value of 0 and standard deviation of 1. And it is done with calculating mean and standard deviation. So for your entire column, you're going to calculate what's the mean value, what's the standard deviation. So according to that, For your value, what you can do is you can subtract it with your mean value and divide it with standard deviation. So after doing this entire thing, your column will be having, if you take the mean value, it will be 0, and if you take the standard deviation, it is going to be 1. That's the idea, and this can be done with StandardScaler from sklearn.preprocessing. You can import StandardScaler and do this task. You can fit and transform and then obtain this. And we also have something known as robust scaler, which is going to be which is particularly used when your data set or your column has a lot of null values, a lot of outliers, which is value which is very far in range, which is not relevant with other details, something like this. This is called as an outlier because it's not related with these main categories, it is somewhere else. So to handle this particular data, what you can do is you can go and perform robust scaling, which uses something known as interquartile range to scale the values. So it is going to be subtracting from the median value divided by IQR, your new value, and IQR will be selecting the quartiles from Q3 and Q1, which is the percentile, 25th and 75th, and then what's the subtraction. If you do subtraction, that range is going to be IQR, and it is applied, so they can apply some, for example, here and all we used the maximum value and minimum value, as well as here we went with mean and standard deviation. If you have a larger value, which is, for example, in the age, if I have an outlier, let us consider an outlier of 120 in the age instead of 12. If you go, I have 120, it is actually an outlier which is not possible here. You have to remove it or you have to fine tune it. Instead, if you just take that and go and perform normalization, then for all the values, the minimum value will be same, but the maximum value will be 120, which is hardly going to change all the values range, and it is going to give minimum importance to other values. Just perform this calculation, you will understand. Similarly, if you go for standardization, when you pick or take mean value, this 120 is going to shift your mean value towards its side, and it is going to obviously affect it when you go for standardization. So in these processes, we can simply pick a robust scaler for this, which is going to use the IQR range, so which will give least importance to the outliers. It's a good scenario. If you have outliers, go and use robust scaler from sklearn.preprocessing. And this is like, which is better when when to go for normalization, when to go for standardization, when to go for robust scaler. Then we are going to talk about encoding. So before that, I hope we can just practice the scaling which I have done. So for example, I'll go and pick the particular data once again, which is the diabetes data set, and I'll show you how to perform this .hit. So we have a lot of column values. For example, if we just go with let's go and call data of glucose, and what I can do is first I'll go and call from sklearn.preprocessing import when max scaler, or any scaler you want. You can just go and create an object, just import it and create an object in the name like scaler and call min max scaler, and you can just go and fit it here with passing data of glucose. Once again, it's going to be, I'll go with scaler.fit underscore transform and pass this entire thing, and go with, let us go with, yeah, that's it. You can pass it as a 2D, so it can be done. So now this value has been scaled. So if you just look at the head of this glucose, it will be particularly scaled. In the glucose, you can see a lot of decimal values will be available. So what is that decimal value is denoting as? It is between a range of 0 to 1. If you have a doubt, what you can do is you can go and pick that column to find the minimum and maximum value, and that can be just done with the help of data of glucose dot minimum will be 0 now, and the maximum value will be 1 here, and all the values between that range. Like that, you can do it. You can use a loop to do it for all the columns, or you can entirely also do it will be handling that. So this is a process of scaling. We'll be doing it for other columns as well. Just leave your outcome or the label column. And moving into the next part, which is called as encoding. So what is encoding? So machine learning models can only work with numerical values. Okay, since they are a statistical tool, you can have or work only with numerical values and you can't have any text. What if I have a text? Okay, you can go for this feature encoding, which is going to give or some numerical representation. What if you have a data set something like this, where the gender is given as male and female? So instead you want to turn them into 0 and 1. What you can do is you can just go and use encoding. And for the encoding you have different methods like nominal encoding or ordinal encoding. Mostly we prefer to use ordinal encoding. So when you go for ordinal encoding, you can do it with label encoder from the sklearn pre-processing. So if you have team like A, B and C, it is going to assign one number for them. For example, for the A team it is going to give 0, for the B team it is 1, and for the C team it's 2. And with these things they have been encoded, and the encoded data will be available here. You can fit and transform in the same way like we have done. So for example, let me just pick this data once again, get data.head, and here I'll call the gender column, and for that we need the label. So from sklearn dot pre-processing, I'll import label encoder. So this is going to be, you can create an object or you can directly go with label encoder dot fit underscore transform and pass that particular column. So the encoded values will be replaced in that particular column. So if we now go with data.head, I'll be getting numerical representation. So male is given as 1 and female is given as 0 in this. So like that, name and all you can't encode, they don't have meaning as well, so you can drop this column. So some of the important columns we'll be taking it from here. Some of the columns if we don't want, we'll be dropping it. If we want, I'll be going with encoding as well. So finally keep it in numerical format and keep it in a scaled format, so we can proceed into the next step, which is going to be important one, which is train test split. So before going, I'll pick this data once again, which is our diabetes data. So we'll create a predictive system for it, where it is. This doesn't have any null values, just we need to scale it. So data of, I hope we can, before this we can go and split our x and y. So what is x is data dot drop, I'll pass outcome, axis 1. I don't want outcome because it's the target, so I'll have the target in y, which is going to be data dot outcome. So now we have our x and y. So instead of min-maxing entire data, so I can now go and call x and transform the x alone here. So now your x is a scaled value, which if you check, all the columns will be in the array format, numpy array, and y is going to be the respective label for it. Like in the yesterday session we have seen, right, circle, square and triangle, that respective labels are here. It's a binary classification problem. So for this we are going to perform train test split. So what is this train test splitting is? We are going to split the available data. In machine learning technique, the train test split is a technique used to evaluate the performance of a predictive model, and the basic idea is to split the available data into two parts. So one part is used for training the model and other part is used for testing the model. So it's like if you have 100 questions, you are going to pick something around 80 questions for the student to learn. So after learning, you are going to give the remaining 20 questions for the student to give some answers, so that you can evaluate on him like how much he have done well or not. So if the model is not performed well, you can ask it to retrain, or you can choose some other parameters and you can train it more. So the basic idea is to split. One part is used for training the model and the other part is used for testing the model. So to do this, you can go for sklearn.model selection. You can import train test split, where you can go and create 4 variables and then you can call train test split. You can pass your x and y values, and you can go with a test size and random state. Test size is going to determine how much should be splitted for testing. Like if you go with 0.2, it is 20% for testing, and remaining 80 for training. Okay, so this is train test split, and these are the train test split parameters. I hope so. So we can go and call, for example, we have our x and y, so you can go and call from sklearn dot model underscore selection. You can import train test split, and your x train, the x test. So x is splitted into two parts, that's the idea, and then y train, y test. Y is also splitted respectively into two parts. You can call train test split, and you have to pass your x, your y, and the test size, which is I'll go with 0.3, which means now 30%, and then I'll go with a random state, which is a parameter to produce reproducibility. So this number, or the 30% for testing, is picked randomly, and if you go with the same random state every time, you get the same 30% every time, so you can have reproducibility. That's the idea. And I'll split it. So the total data dot shape, let us look into it. So I have a data with shaped 768 rows, and now my x train will be having a shape of 70% on training, which is 537 rows and 8 columns, because one column is there in y train. So the y train should have the respective shape, same but one column, 537 rows and one column. For testing, we have x test dot shape, and that is 231, which is the 30%. You can also have its respective answer, which is y test 231. So with these things, what is the next step is, if you are a pro, you will be going with feature selection. If you are a beginner, what you can do is simply skip this and move into a part which is called as how to choose the right machine learning algorithm, because these are the very basics and proceeding with the algorithm. So one of the algorithm, if you go and check, it may or may not perform well, because this is just a data which is, the number of rows is very less than 1000, like 700 rows is not even a data set, I'll tell. This is for practice, and in a real-time scenario you'll be having lakhs of rows. At that scenario, you can't directly jump into algorithm. You have to go for feature selection and feature mapping. So a lot of process can be done, and then parameter choosing, and then training and all will happen. So basically, if you are a beginner, you can start with choosing the model. So first you have to decide what type of algorithm you have, or what type of project you are going to solve here. So if I look into that concept, I'll be having an idea like this is a supervised learning problem, and under that this is a classification problem, and under that this is a binary classification problem. So that's the idea. So for binary classification, or you have to consider what's the nature of the problem, and the nature of the problem here is binary classification. So there are a list of binary classification algorithms are available. And then what are the nature of algorithms? So for binary classification, you have like for classification itself, you have naive Bayes, decision tree, support vector machine, random forest, k nearest neighbor and all. So with these algorithms, what you can do is you can pick that, and you have to understand what and when should be which is used. For example, decision tree, random forest and all are algorithms which are tree based structure. So if you have a data set which is having a lot of categoricals like gender, and then yes or no kind of situations, or a lot of in your data set, you can go with decision tree because they work well in that. You can't go with a numerical column there, it will be failing. So in such scenarios, you can go and use some other like logistic regression, linear based algorithms. So you have different algorithms, you can pick one from here, and you can also compare the performance of it later on. So first we'll pick algorithm and try to evaluate it. For example, let me just go and take from sklearn dot linear underscore models, import logistic regression. Okay, it's linear model, we have logistic regression here. So LR is going to be, I'll create object for this logistic regression. So you can go and first fit it with lr.fit. I'll pass my training data. So this fitting is the part where you are training your algorithm or making it to learn to find this pattern, and you have x train and y train, their values, I'll pass it. So the fitting or training is happening now and it is done. So after training, what you can do is you can ask it to predict, for example, lr.predict. So if you pass X test, which is the questions or the features, it is going to give you the target, which is a Y test, but this is a predicted one of ones and zeros. So I'll go with Y predicted equal to this one. So if you look at the shape of Y predicted dot shape, it is going to give you the number of columns you have, rows you have 231. And if you look at the original answer, which is in Y test for that X test questions, you will be having it 231. So these two match because this is the original one and this is the answer from my algorithm. So for evaluation, what I can do is I can go with accuracy score. So that is available in from sklearn.metrics, import accuracy score, and I can pass accuracy score and I can pass original answer and then the predicted one. So this entire answer just multiplied with 100, you will get a percentage, and it is telling me that 74% of answers was correct, which means that if you take out of this 231, okay, so 75% in this 200, like for example nearly 160 or 170 questions was correct, remaining 60-70 was wrong. That's why it is giving you 75% answer. You can also get this in sns.heatmap, and instead of accuracy score you can also get confusion matrix, and you can pass that confusion score matrix, pass your Y test and predicted values. Come on, let us go with format equal to 0.1f, annotation equal to true. Let us view it. So this is a heat map of how many correct and how many wrong answers. 0 correctly predicted as 0. So for 0 answers, 127 was correct and 35 answers were wrong. And 1 correctly predicted as 1 in 45 places. In remaining 24 questions, the answer was wrongly given by your model. So it performs 75% good. So we'll pick some other high-end algorithms, like from XGBoost, I'll import XGB classifier. This is for classification. So the XGB here equal to XGB classifier and the XGB dot fit X train and Y train values, and then XGB predicted equal to, I'll ask it to predict, so XGB dot predict, I'll pass X test values, so the XGB predicted dot shape will be 231 once again. So for this evaluation you can go and call the same accuracy score, but instead of Y predicted you pass XGB predicted here, which is okay. This performs 72% well, which means that your logistic regression was performing really well. So we may need to change its parameter and move further. So in these ways, okay, so if you pick different algorithms and if it is not improving in that very well, what you can do is you can go and pick these properties, which is called as feature selection. So we'll go back once again. It's like a trial and error method. So going with feature selection, what they do is it is the process of reducing the number of input variables when developing a predictive model. So it is desirable to reduce the number of input features. Like you have given 8 columns, right? How much you are reducing it, that much complexity you are reducing and making it easy for your algorithm. So for these processes, you have different selection methods, and mostly we prefer chi-square test, ANOVA F value, mutual information. These two are very basic. So looking into mutual variation, these three are actually mutual information and like chi-square test, F ANOVA test. So all these things are some of the statistical methods used to select some of the best features. So it's like you can use this, which is available, which is called as select k best, which is available from sklearn.feature selection. And if you pass what method you are going to use, like mutual info regression or F underscore class F or ANOVA test, and then if you pass number of columns you require, you can fit it and get it in get underscore support. So these things are taken and this process goes on, like you will be collecting some important columns, training and testing it, you try to improve it. So over the time you can find, for example, if some algorithm is performing well, you can take it. For example, here we'll imply another algorithm at the last for the same process. Let me just repeat it from sklearn tree. Let us import decision tree classifier. Here I'll mandatory, instead of xdb I'll pass this decision tree in the name of xdb itself and get the percentage of how it works. Okay, so this, as I told, decision trees or tree based algorithm would work well. So initially our logistic regression was worked really well. So to improve this, we can go and work with feature selection. So in these, who has importance, so you can manually find that to, for example, data.correlation. It is going to give you a table of how one column is related with the other. You can view it in a visualization with heat map and format of 0.1f, annotation true, and column map I'll go with blues. So it is going to give us a graph of how one is related with the other, how much it is either closer to 1 or closer to -1, that is more correlated. But if it is closer to 0, then it tells that they don't have any relation. So if you look at it in that way, the outcome of diabetes has high correlation, which is 0.5 is the highest correlation based on the glucose level. As we all know, glucose level will determine diabetes, right? So they have 0.5 correlation. Apart from that, blood pressure and skin thickness, insulin and all, they have very less correlation. Body mass index have 0.3 correlation, and diabetes pedigree function and age has 0.2 correlation. So if you ask me to pick important columns manually, I'll be picking glucose, body mass index, age, diabetes pedigree function, like also pregnancy. So I can pick these 5 columns and train this model on picking the outcome, and it is going to give me some good results, which I can tell you now itself. So that's it about the machine learning basics. Any doubts you can post in chat box, or I can wind up this session. Any queries about this, which we have seen in the past 1 hour? Apart from attendance, if you have any other doubts in this particular process, you can post it down in chat box. So that's it. Thank you. Thanks for watching. You can leave this session. Thank you. And please subscribe and follow our YouTube channel, Pantech eLearning, Digital Learning Simplified. I hope we made justice on this data collection, pre-processing, train test split, feature selection, model selection and training, predictions, evaluation and improvement in a nutshell. Thank you all.